Good afternoon. Welcome back to the our chemistry basics. Today we'll see the P block elements. In the periodic table, P block elements normally the 6, 13, 14, 15, 16, 17, 18 we'll see. But the last one, that is the 18, we will not consider because that is the zero group elements and all. So now group 13, we'll see today in the first year group 13 and 14 are only there. So there are so many interesting topic, I mean some variations in this unlike the S block. So now first group 13, what are the elements? Group 13, the elements are boron, aluminum, gallium, indium, allium, and this here we will stop it because the last one was in normally the radioactive type and all these things. Then 14 is the carbon, silica, germanium, carbon, silica, germanium, tin lead. Then group 15, boron, carbon, then nitrogen, phosphorus, arsenic, antimony, bismuth. Then 16 fellow is oxygen, sulfur, selenium, tellurium, and polonium. Group 17 we will see the fluorine, bromine, iodine, astatine. 18 I am removing, and the last also we are removing. Out of 6 only we are considering only the 5. In this also, in this first year it is only 13 and 40 the P block elements. Okay, these are the interesting these things. If you see the P block generalized statement, the electronic configuration will be NS2, that is the first for the up to beryllium and all. Then NP 1 to 6. So here other than the helium we are not at all considering, and 18 group also I am not considering, that is inner core and all. The here we will consider one by one, like the what is the oxidation state, what is the other than the normal oxidation state, what is the variations, and how the variations compared to the S block and all these things also we will consider. Okay, and now the first that group 13 we will take. In this the boron is 5. Okay, we can consider all the boron, carbon is 6, 7, 8, 9. So in this family, boron family, that means the group 13, the normal oxidation state is 3, because it is 1s2, 2s2, 2p1. It is only 1, but here from here it will jump to in the p1. So total 3. So normal oxidation state is, means group oxidation state is 3. That is called group oxidation state. Remember the words carefully, it is called group. There will be some exceptions. Group oxidation state. You understood that why 3? 1 is in the P, 1 from S will jump into the P, so total it will be 3. 1 in the P2, only 1 S. So total 3, that is a group oxidation. But sometimes it gives the +1 also. +3 is a group oxidation, +1 also sometimes it will show. That is in the third group. If you see the carbon group, that is group 14, the normal is this is 1s2, 2s2. We are not considering the first fellows, so 2p2. So normal group oxidation is 4. How? This 2 and 1 will jump from here. So 3 in the P and 1 will be S, totally 4. So normally group oxidation will be the 4. Exception is +2 and -4 also. Exceptions are +2 and -4. Whatever I am writing is exceptions in the bottom. The first one is group oxidation. Then this is the 14th group, this is 13th group, carbon family, this is a boron family. Then next fellow is nitrogen family, group 15. In this, same 1s2, 2s2, 2p3, 3 plus 2, 5, only here there is no jumping mechanism. So it is only the half-filled fellow. So normally group oxidation is plus 5 and sometimes +3 and -3 also possible. These are the some other exceptions, other acceleration states. Then group 16, nitrogen, then it will be the oxygen. Oxygen is oxygen, 1s2, 2s2, 2p4. 2p4 is supposed to be +6 state, the group oxidation, and but the normal fellow is +4, +2, -2 and all in the group. How it can happen? Here there is no vacancy also, only there are 2 vacancies. So +2, -2 is okay. When it is combining with the fluorine, +2 is also okay. So how the +4 and +6 and group oxidation states only just by adding is it, or how the +6 state is coming? Here is the question. Between the first, other than the first 2 elements, that means in a group, if you see boron, carbon, nitrogen, oxygen, fluorine is the first fellow periodic, second period afterwards, there is a D block. Here also D block will be there, but here in the first 2 cases the D block is vacant. D is vacant. After onwards, D is filled. So because the D is filled and D is vacant, here there will be so many other variations is coming. Okay, so because of that this +6 is coming and the +4 is coming, +2 and -2 and all for some elements, but not for the, this is not valid for all the oxygen is cannot be a +6 at all. So it is a +2, -2 and this thing. Sulfur is having a different because it is a D vacant orbital. So some of the electrons is jumping and all. We will see when it is coming to the particular element. Okay. Similarly, 17 is the fluorine group. Fluorine is the group oxidation state is +7 and +5, +3 and +1 and -1. Normally fluorine will be only -1. So from chlorine also -1 only. Then onwards there will be so many variations and all. So that will be the this thing. Interestingly, this all boron, carbon, nitrogen, oxygen, fluorine are all non-metals. In the particular these 5 groups, there will be some metalloids, and at the bottom there will be some metals like lead, bismuth and thallium, polymer type things. There will be means from top to bottom the metallic character is increasing. From left to right, non-metallic character is increasing. So those things are the common for the in the periodic table, whatever it is, that is same as it is are existing, and that is normally following. Then comes to the, so because of this non-metallic character, their ionization potential or ionization energy, ionization enthalpy is more. That means they are not ready to lose the electron, they are ready to gain the electron. So there will be normally the minus signatures, and they are ready to gain the electron, not ready to lose the electrons. So that is the another one change. So now if you say the first P block differs from the remaining members, like the other this thing. In the two areas it is different. First in the size it is different, and the first elements are differing from the others, and two areas. One is in size. That means like the lithium and beryllium and all. The second one is because of the D block elements. It is because of the D block elements variation will be there. The covalency bonds will form. That means in the BF4 or aluminum, BF4 is minus, aluminum tetra hexachloride minus 3 ions. In this there are so many variations in this. Similarly, there will be variations in like a diatomic molecules, nitrogen triple bond nitrogen, and carbon triple bond carbon, and carbon triple bond nitrogen, nitrogen double bond oxygen. There are so many variations will be there in these things. So in general, so tomorrow we will see the particular group of 13 group only. You have 13 and 14. This is all in general, and this thing. So we'll see how the boron family, there is the 13 group elements, boron, aluminum, gallium, thallium, is where the availability, how the radial configuration, ionization potentials, and what are the elements, and what are these things, and where it is useful, what is the availability, and all these things tomorrow we'll see. Okay, thank you.